Right, so if they belong to each other, you write it as a coordinate. But this x belongs to a point, and this y belongs to the midpoint, so they don't belong together. Did you get those two right? Sharp. The next one, midpoint given or part of it, and then unknown, basically the same. You work it out, x to be -1, y to be 8. Happy? Okay. Then at 3.3, they gave you the distance of the line. Okay. There's only one unknown. That's why it's fine for us using the distance formula. I substitute into this one, the one without the square root, because I want to find out one of these. Now, I said to the Afrikaans class as well, if I do these sums, before I substitute, I pay some attention as to what it is that I want to calculate. In other words, I want to calculate this y, right? Now it's easier, it's not undoable if you don't do this, but it's easier if your variable is the first one in your bracket. If it's the second one, you can still get it right. But it's just another hurdle in your way of getting to the right answer. It's a place where you can make a mistake, because we're not normally used to it like that. But if you don't do it, it's not wrong. But I always look to get my variable there alone. Then when you square it out and you simplify, you get y squared minus 8y minus 48. Now I want you to look at me and tell me who squared this to y plus 60. Nobody. Did you square that binomial to become a trinomial? Y squared plus 16. Who said that? Did you do it correct? Okay. Remember, 2 terms squared becomes 3 terms. And then you get your two answers, 12 and -4. Now, they didn't indicate any more information on where this point is or whatever, so you gave both answers. I'm just going to move it up and move on to question 2. So the information that they gave you was they gave you the coordinate of A, B, and C completely. The one that's unknown is D, or partly unknown. Then for the first question, they tell you that AB is parallel to CD. What does that mean for us? It means that the gradient of AB, the gradient of AB will be equal to the gradient of CD. Now I asked you guys not to peek at the solution, because the way that they did it in that in those examples is a bit of a more difficult way. They let the two be equal to each other and then they complete it from there on. If you did it like that and you understand it, then it's fine. I would rather have calculated the gradient of AB first, and it turns out to be a third, and then use that third going further. Because they are parallel, I know this gradient sum must also be equal to a third. And then I said to the Afrikaans class as well, be careful with your substitution in the gradient. The two that's underneath each other has to belong to each other, so they will be a coordinate. If you start with C's or with D's y first, you're going to have to start with D's x first. If you put C's y second, it's going to have to be C's x second. Got it? And then it looks like this. Now, I don't know if you all remember this. It's that shortcut. I taught it to you in grade 8 as well, no? If your unknown is the denominator, then you can take the denominator and swap it with the answer. You do that without changing any signs because it's just a shortcut. But if you went through the steps of multiplying this on this side and then dividing with a third on this side, then it's fine as well. The shortcut just makes it quicker. Okay. When you divide with a third, it becomes multiplication with the reciprocal. So therefore, x plus 4 is equal to 9, and then x works out to be 5. Who got it right? Good. Can we go on to 2.2? Everyone done? Quickly, quickly, quickly. Two point two was very much the same, except they said that AB is perpendicular to CD. So you're going to use this gradient again. But instead of saying CD's gradient is equal to a third, we're going to take a third, swap it around, and give it a negative. So therefore the gradient is going to be equal to negative 3. Let it be equal to it, and then once again I just swap my denominator with the answer, and my answer turns out to be x equal to negative 5. The last one was on collinear points. So they ask you to show that B, C and D are collinear. That means that the gradient of BC is the same as the gradient of CD. Do you see there's my common point? C is in both of them. So I only need to calculate 2 gradients. So I'm calculating BC's gradient. It turns out to be 3 over 5. Then I substituted CD's gradient. That gradient must be the same as 3 over 5. So I let that be equal to 3 over 5, and then I said to the Afrikaans class, this is also just a shortcut. If your numerators are the same, there's no calculation in there. You can just work with the denominators. Okay. But if you did it the long way, you will get the same answer, x equal to 1. Everyone done? Okay. So I said to you today we're going to look at the properties of the quadrilaterals, the different quadrilaterals. So if we can work there in our books, I need you to write it down, because if you're going to write it down, that means you're going to know it a bit better already. Scrap? Oh, color pen. Please do. You can always use color pen. Alright. Okay. Now when we think about quadrilaterals, I need you to think about it like the different doctors that we get. Okay. Do you know you get different types of doctors? Okay. So The doctor that you go to when you have a flu is called a GP, ne? General practitioner. The doctor that you go to if you've got a heart problem is going to be a cardiologist. Right. That cardiologist was a doctor first. He was a GP first. And then he specialized to become a cardiologist. The same with a neurologist. He was a GP first and then he specialized to become a brain doctor. Right. So if we think about a cardiologist or a neurologist or a surgeon, they are all doctors. Right? All neurologists are doctors. All cardiologists are doctors. All surgeons are doctors. But not all doctors are cardiologists. And not all doctors are neurologists, and so forth. Okay? So the GP of the quadrilaterals, the general practitioner, the doctor, is going to be the parallelogram. Now the reason I'm saying this is because you need to understand that when I look at the neurologist, he already has everything that the GP has. So when I look at a rectangle is already a parallelogram. All of the properties that we're going to see with the parallelogram is in the rectangle as well. They just got something extra with it. Right. So we're going to draw a parallelogram nicely on scale. Doesn't matter what you choose the length of the sides to be. They must just be the same, ne? Now we're going to look at the length of the sides, or the properties of the sides, the properties of the angles, and then the properties of the diagonals. Quickly look here. I need you to pay attention. In previous years, we often wrote it as A, B, C, D. Ne? Then it's parallelogram A, B, C, D, which is wrong. Okay? If we are going to call this thing parallelogram A, B, C, D, then those letters need to follow each other. So it's going to be A, B, C, D. Now you will see when we get to the old examination papers that this plays a very important role. The way you know where that letter or where that dot is going to be is going to be according to the order of the letters. Alright, the first thing we're going to look at is the sides. Do you agree with me? It's got, a parallelogram has got two pairs of opposite sides that are equal. And it's also got two pairs of opposite sides parallel. Now when we're going to look at the paper that's in your book, you will also see when you have to prove something is a parallelogram using the sides, you can either say, or you can either prove that two pairs opposite sides are equal, then it's a parallelogram. Or two pairs opposite sides parallel, then it's a parallelogram. Or one pair of opposite sides equal and parallel. That makes it a parallelogram. but it's in your book as well. That's not as important right now. If I look at the angles of a parallelogram, are the angles all equal to each other? No. Can you all see that? But if I look at this one and this one, they will be equal to each other. And this one and this one will be equal to each other. So we've got two pairs of opposite angles equal. The third thing we're going to look at is the diagonals. So let's join them, AC and BD. Are those diagonals equal to each other? Are they the same length? Take your ruler, or you can look here. If I measure the diagonal AC, it's around about 4.5 centimeters, mine. And if I measure the diagonal BD, it's almost 7 centimeters. So can you see they are not equal? Okay. But there is something special about them. And that is that the diagonals bisect each other. What does bisect mean? Not just cut. Cut in half. Okay. That means this side is equal to that side and this side is equal to that side. Now, this is an extremely important property of all the doctors. All of them. Now, what this means is if the diagonal AC is being cut in half by BD, it means that that is the midpoint of AC. And if AC is cutting BD in half, then it means that is the midpoint of BD. Do we have something about a midpoint in analytical geometry? Yes, we have the midpoint theorem. So if two lines bisect each other, it means that they have the same midpoint. So for example, let's say you've got information here on this parallelogram. You've got the coordinates of A, you've got the coordinates of C, you've got the coordinates of D, or whatever. You want to find the coordinates of B. It's two unknowns, no? X and Y. So you cannot use the distance formula. We can only use the midpoint formula. But now we don't have the midpoint of BD to help us to get to the coordinate of B. But we can find the midpoint of AC. And if you find the midpoint of AC, then that is also the midpoint of BD. And then you can calculate B. Does that make sense? Very important. So all of the quadrilaterals, these ones that are doctors, all of their diagonals bisect each other. Okay. You can highlight that one, that property. Okay, that's the first doctor we have. Then we're going to move on to the cardiologist. So what is a rectangle? A rectangle is a parallelogram. But with extras. So, when I draw my rectangle, I already know that it's got two pairs of opposite sides equal to each other and parallel to each other. I'm not going to rewrite those properties again. I already know that it's got two pairs of opposite angles equal to each other. But there's something different on about these angles. No? They don't just have two pairs that are equal to each other. With a rectangle, let's just call it again ABC. In this rectangle ABCD, along with the parallelogram properties, it's got four angles equal to 90 degrees. That's added special. Because this is a parallelogram, we know that the diagonals bisect each other. Do any one of you notice something special about the diagonals? No. They're equal. You see that? AC and BD are the same length. That's the something special we have here. The surgeon we have here is the rhombus. So he's also a doctor. It's a parallelogram with extras. Now just looking at it, do you think a rhombus is also a rectangle? Does it have the same properties as a rectangle? No. A rectangle has got four angles equal to 90. I can already see it doesn't have that. So it's not, the neurosurgeon, the surgeon is not a cardiologist. They're all doctors, but they're not the same doctor there. But because this is a parallelogram, I know that it's got two pairs of opposite sides equal and parallel. But what is special about these sides? That all four of them are equal. I know this is a doctor, so therefore it's got two pairs of opposite angles equal. Can you see that they're not all equal to each other like the rectangle? The A and C are obtuse angles and B and D are acute angles. They're not the same. So the difference here is all four sides equal. Nothing funny with the angles, it's the same as the parallelogram. Now let's look at the diagonals. I know that these diagonals bisect each other. Are they equal to each other as well? If you're not sure, measure it. Okay, even if you're in a test, go and draw a rhombus. Doesn't have to be perfectly on scale. You will see BD and AC are not equal to each other. So there's nothing funny there. But there is something special about a rhombus. There are actually two things special about a rhombus's diagonals. Can anyone see something that it's doing that it didn't do in the parallelogram? Wow. What sides? What are you referring to when you say sides? Yes, is that what you were trying to say, Mao? But what are you saying is equal? Now we have that, we're busy with the diagonals now. We already said all four sides are equal. Okay, we're busy with the diagonals. So see, I'm saying they are perpendicular. And this is extremely important. Extremely. Now the other thing that these diagonals do that's special, but it's not really something that we use a lot. But you can indicate it on, we're not going to write it down, but we're going to indicate it on our sketch, is it bisects those angles. Do you see that? It cuts angle A in half, which means those two angles will be the same size. And it cuts C in half, which means those two will be the same size. And it cuts D in half, meaning those two will be the same. And it cuts B in half, it means those two will be the same. Which makes perfect sense if you consider this is an isosceles triangle. And this is an isosceles triangle, and this one, and this one. They're all isosceles. But we're not writing that down. It's not important for us in analytical geometry, and I will tell you why. Because in analytical geometry, we work with lines. Ne? Parallel lines, perpendicular lines, the length of the lines, the midpoints. We don't work with angles. So we won't be able to calculate the size of those angles. Right now we get to the big main Pickawyn quadrilateral. And that is the neurologist, neurosurgeon. I don't even know what will be the biggest, best doctor. But this will be a square. Now a square is a parallelogram. But a square is also a rectangle. It's got exactly the properties of a rectangle. And a square is also a rhombus. And then it's got some extras. It's actually got a combination. So we are going to draw the square. And because this is a parallelogram, I know that it's got two pairs of opposite sides equal, but it's also a rhombus. So it's got all four sides equal to each other. But we'll get to that now. It's got two pairs of opposite sides parallel. So what is the special thing here in comparison with the parallelogram? It's all four sides equal to each other. But do you notice that if I have a parallelogram, if they tell me it's a parallelogram, and they want me to prove that it's also a square, and I prove that all the sides are equal, I haven't proven it's a rectangle, a square. If I only prove all four sides equal, I have proven a rhombus. You understand what I mean? Right, looking at the angles, because it's a parallelogram, I know I've got two pairs of opposite sides equal, but these angles are special because they're all equal to each other and equal to 90 degrees. So if I have a parallelogram and I prove the angles are 90 degrees, I haven't proven that it's a square, I have proven that it's a rectangle. Although it is a property of the square. Now looking at the diagonals, because this is also a parallelogram, I know that the diagonals bisect each other. Do you notice something else about the diagonals? They are equal. Who else has diagonals that are equal? Rectangle. So proving the diagonals are equal, you're not proving a square, you're proving rectangle. Do you see something else there that's special about the diagonals? They are also perpendicular to each other. Who else has got that property? Rhombus. So that's a property of a rhombus. Now you will ask me, okay, but ma'am, what then? You are saying, if you prove this, I haven't proven it. If I prove this, I haven't proven this. You remember when we said, when we looked at the rhombus after the rectangle, I asked you, do you think a rhombus is a rectangle? And you all said no, ne? We agreed on that. A square is a combination of a rhombus and a rectangle. So if you want to prove a square, you're going to have to prove it's a rhombus and you're going to have to prove it's a rectangle. So it won't be enough proving that all four sides are equal and the diagonals are perpendicular, because then you've just proven rhombus. But if you prove that all four sides are equal and then you prove that the angles are equal, all four sides are equal to all four angles are equal to 90 degrees, then you've proven a square. Or if you prove that the diagonals are equal and you prove that all of the sides are equal, you've proven a square. Or any other combination where you prove it's a rectangle and a rhombus. That makes a square. Does that make sense to you all? Okay. But it's important for you to know this extremely well. Do you see how close to the same it is? But yet it's so different. So please look carefully there. Right, then we've got two more quadrilaterals. They aren't doctors, but they are also in the medical profession. They are quadrilaterals, but they're not parallelograms. Okay. Do you know what they are? I think that the trapezium. Ja, mevrou? Nee, mevrou, dis nog die 5de periode. The trapezium, I think, is maybe a physiotherapist. Okay. Still in the medical profession, but not a doctor. Okay. Now, a trapezium, and I'm not taking anything away from a physiotherapist for saying it's a physiotherapist, but the trapezium only has one property. It's a quadrilateral. That has one pair opposite sides parallel. That's all it has, okay? And then on Monday we will quickly have a look at the last one, the chiropractor. Okay, the kite. Alright, the kite is also very different from the doctors. Please, since you have an entire weekend with basically no homework, I need you to go and look and learn the analytical geometry formulas. Go and look at the way we did the sums and go and learn this. And if you've got some time left, go and do a geometry question of the Euclidean geometry to refresh your memory. Okay.